Hello students, welcome to the review, lecture 10. We're still reviewing for our calculus course, going through some important tools that we're going to need this semester. And in this lecture, we're going to talk about geometric approach to functions. All right, so let's start with the definition. And our definition would be like this. We define the graph of a function, the graph of a function to be the graph of the equation y equals to f of x. So that's our strict definition, but how do we use in practice? So let's see. So let's do a bunch of examples. So the first example we're going to do is asking us to sketch the graph of f of x equals to x minus 3. So we'll start with something simple and move to the harder ones. All right, so what would be our solution in this case? Our solution in this case would be let's see what we can do. We can create an equation y equals to f of x. So we'll say y equals to x minus 3. That's our equation that we're going to use. And since it's a straight line, we have to create a couple of points. So maybe the table is a good way to put it. And let's create y-intercept first. So to create y-intercept, we're going to take x equal to 0, right? So this would be our y-intercept. So if we take x equal to 0 and plug it in, we're going to get y equals 0 minus 3, which is negative 3. So we're going to put it over here. And then over here, we're going to create x-intercept. And to create x-intercept, we're going to take y equal to 0. So we're going to get 0 equals to x minus 3. Then we're going to add 3 to both sides. So we're going to get x equals 3. So now we have our intercept, so we can sketch the graph. So to sketch the graph, we create x and y plane. So we go and we create y-intercept first. So for x it's going to be 0. We go negative 1, negative 2, negative 3. So this will be our first intercept. And this is negative 3 value, negative 3. And then on the x-axis, we also go 1, 2, 3, and this point over here will be our second point. And then we create a straight line through these 2 points. And we have a sketch of our graph. As I said before, we start with something easy and we move to harder things. So let's do the next example. In this example, we have the following function. We have to sketch f of x equal to absolute value of x. All right, so that means what? That means we have to create our equation y equal to absolute value of x. And if you remember, strict mathematical definition of absolute value of x tells us that it's going to be x if x is greater or equal than 0, and it's going to be negative x if x is less than 0. And as I said before, when we're dealing with absolute values, we would rather go by cases. So we have a case when x is greater or equal than 0. That's the case that we're dealing with. And if x is greater than 0, greater or equal than 0, then y equal to absolute value of x is going to be equal to x according to the definition. So again, we can create a short table here, x and y. So if we take x equals 0, y will be 0. And and since we have origin as our x-intercept, and origin will also be the y-intercept, because if you plug in 0 for y, you're going to get 0 for x. So this doesn't make sense, so we have to make up a new value for x or y, doesn't really matter. I will make up an x to be equal to 1. If x is equal to 1, y is also equal to 1, according to the definition, right? So if you take 1 and plug it in over here, you're going to get 1 for y. So this case is done, so we can go and plot it. So that means we start at 0, 0, and we go to 1 and 1, so it's a straight line going this way. And now we have to move to the case 2. In this case, we have x is less than 0. If x is less than 0, we have y equal to absolute value of x is equal to negative x, because we're in this case. So we get negative x for y. All right, so let's try to build a small table, x and y. So if we use negative 1 for x, we plug in negative 1 for x, we're going to get 1 for y, because y equals minus minus 1, and it's equal to 1. And we need another value for x, like negative 2. So y equals minus minus 2, which is 2. So now we're ready to plot the values for the second case. So at minus 1 we have 1, and at minus 2 and minus 2 we have 2. So basically it's also a straight line going this way. I messed up a little bit, but so we have this V-shaped graph for the equation. So the only thing to worry about, what happens over here, since x is strictly less than 0, we would have to put a hole for the left line inside of the origin, but it's also defined for the right piece, so it's fine to just have it filled in, because for the right piece it was perfectly fine here. All right, so this is our absolute value function. All right, so we're moving to the next example. Next example, we're going to do the following sketch. So the assignment says sketch f of x equal to x squared minus 4 divided by x minus 2. Okay, so we have a fraction here, so we have to be worried about the domain. So what happens if x minus 2 is equal to 0? So we'll start with the domain here. So if we add 2 to both sides, we're going to get x equals 2 is the place where the function will be undefined. So we don't want x to be equal to 2. All right, so basically everything before 2 is fine, and everything after 2 is fine, but 2 itself is the value of the function is undefined. All right, so what happens when x is not equal to 2? We can look carefully at the equation and try to simplify the equation. Y equals to x squared minus 4 over x minus 2 when x is not equal to 2. So let's look at the numerator. Once I told you about this formula that is really useful this semester again. Exclamation point, and exclamation point. This really important formula we'll be using it every time pretty much. So a minus b, a plus b, the difference of squares will play a huge role. Why it will play a huge role over here? Because if we think about x squared minus 4, we can think of it as x squared minus 2 squared, since 4 is 2 times 2. So according to this rule, we can write it as x minus 2 times x plus 2. How does it help us? Let's look again at our function. For the numerator, we can put x minus 2 times x plus 2 divided by x minus 2. And a lot of people would want to do this, and it's usually called canceling, but it's not really what we do. We don't really cancel, we're actually dividing. But if we're dividing by something, we don't want to divide by 0. So in order to avoid division by 0, at the end we have to say we do not consider x equals 2. And this allows us to divide. So basically it tells us that y is equal to x plus 2 from here when x is not equal to 2. And x is not equal to 2. Oh, look, x plus 2 is just a straight line. So we should be able to plot it easily by creating 2 points. So we take x and y, we take 0, we plug it in for x to get y equals to 2. Then we take 0 for y, so we get 0 equals x plus 2. And if we subtract 2 from both sides, we're going to get x equals to negative 2. So finally, we can make a sketch of this line. So y-intercept is at 2, 1, 2, so it's over here. X-intercept is at negative 2, negative 1, negative 2. So we draw a line going through these 2 points, and we think we're done, except what happens here? The function is undefined, so let me put some more values here. This is 2, this is negative 2. So I have to go to x equals 2, but look, on my picture I have a value, but this tells you that there is no value. So how do we deal with it? So there is a little bit trick that we have to perform. Trick tells you that you take x equals 2 and you actually plug it in into the simplified version. So plug it in into y to get 2 plus 2 equals 4. So we know this value over here is 4, but since we can't really use x equals 2, we have to go back, erase this, and put an empty circle, because the function is actually undefined. And this would be our picture. So it's a straight line with an empty hole in x equals 2, y equals 4. There is no actual value. All right. Okay, so we're moving on to a more complicated example. In this example, we're going to sketch something like an absolute value function, but let's see. I'm trying to not to be ahead of myself. So sketch f of x equal to, and it's a piecewise function. Piecewise function means function consisting of different pieces. So let's use x plus 2 when x is not equal to 2, and use y equals 6 when x is equal to 2. But we actually did plot this function before over here, so I'll just reuse my values. So x-intercept is going to be at negative 2, 0. Y-intercept is going to be at 0, 2. So I'm going to redraw this function. So it's at negative 2 and at positive 2. We have a function going like this. But also it says when x reaches 2, I have a value 6. So here I have to put an empty circle at 2. I mean, I didn't really define it right. My function wasn't defined right. Let's go back quickly and fix it. So sketch the function f of x equals to x plus 2 when x is not equal to 2, and equal to 6 when x is 2. So basically we have an empty circle at 2, but we have to go to 6, 5, 6, and put a filled-in circle at 6. So at 6 we have a filled-in circle because of this, and we have a hole here in the graph because of that. So I made a small mistake, but I caught it in the right time, so I hope you understand it. If not, ask me questions in class. All right, and one more example before we move on goes like this. Goes like this. Again, a piecewise function, and we have to sketch it. So g of x equals equals to 1 for x less or equal than 2, and equals to x minus 3 for x greater than 2. So let's try to sketch it. So before 2 we have y equals 1. So case x less or equal than 2, we have y equals to 1. But remember, y equals to 1 is a horizontal line through y equals through point 0 for x, 1 for y. Okay, so let's plot it. So basically it tells you before 2, including 2, so it means, this means what? That means it's a filled-in circle at the end. I'll use a different color. And it's a line going through 1 over here. All right, and then we have another case x greater than 2. If x is greater than 2, then y is equal to x minus 3. But we can only use values greater than 2. So let's create two values for x and y. So let's use x equals 3. If we plug in 3, we're gonna get what, 0, right? If we plug in 3, we're gonna get 0. So at 3, we're gonna get 0. So it would be interesting to understand what's going on near 2 with this function. So what I'm gonna do my trick. I'm gonna take x equals 2, even though I'm not allowed, but I'm still gonna plug it in over here. So I'm gonna get 2 minus 3, which is -1, and again, my function can't really reach 2, so what I'm gonna do, I'm gonna go to -1 over here. I'm gonna put an empty circle because I can't really use x equals 2, and my function will go like this. And so this would be my piecewise function. Again, empty circle on the bottom, filled-in circle on the top, and it's a piecewise function here. One last thing to finish this lecture would be, can we visually understand whether it's a proper function or not? And proper way to understand this is to use vertical line test. Vertical line test. So what is a vertical line test? Vertical line test tells us whether the function is a function or it's just something which is not a function. All right, so we say the following. We say that a curve is the graph of a function, the graph of is the graph of f of x for some function f if and only if no vertical line intersects the curve more than once. All right, so this is a vertical line test. So basically, if we can find the vertical line that crosses our graph more than in one place, then this would not be a graph of a function. All right. So let's look at an example before we finish this lecture. So in this example, we have our famous circle. So the question is the graph of x squared plus y squared equals to 25 a function? A graph of a function. Maybe that would be better. Is a graph of a function. All right, that's the question. So what do we know about this? X squared plus y squared equals to 25. It's definitely a circle. So circle with r equals to 5 because 5 squared is 25. And it's centered at 0. So h is equal to 0. There is nothing near x. And k equals to 0 since there is nothing near y. All right, so circle centered at 0, 0 with radius r equals to 5. So what we're gonna do, we're gonna create our circle and radius is equal to 5. Now we're trying to see if we draw a vertical line, can we cross it more than once? Right? Can we cross it more than once? Definitely here we have one place where we cross, second place where we cross. So we say does not, or we say maybe, we say this graph does not pass the vertical line test. Does not pass the vertical line test. So it is not a function. It is not a graph of a function. All right, so we did it graphically. We looked at the picture. We saw that if we draw a red line through this particular place, we'll have two different values. But also we can do it without the graph. So we can use just algebra. So algebraic approach would be if we take x squared plus y squared equals to 25, we would like to figure out how many different values of y we can have for one particular x. So we would like to solve for y and see how many different values of y we are going to get to get for a particular value of x. So let's do this out. So we have x squared plus y squared equals to 25. We subtract x squared from both sides, and we get y squared equals to 25 minus x squared. So we take a square root on both sides, so we get y equals, let's remind ourselves, when we take a square root on both sides, we have to introduce plus or minus. So we put plus or minus 25 minus x squared. All right, so basically, for each particular value of x, when you plug it in, you get two different values of y. So let's take x equals 0. If we take x equals 0, we plug it in, we're going to get plus or minus square root of 25, or plus or minus 5 for the values of y. So let's write our conclusion. Our conclusion tells us that it is not a function. Since for a particular value of x, such that minus 5 is less than x is less than 5, because if you plug in negative 5, you're going to get 0 for y, and if you plug in 5, you're going to get 0 for y, so it's not really, it will be fine, but anything else between minus 5 and 5 will not work. So we get two different values of y. We get two different values of y, right? So we wouldn't pass a vertical line test. So I think this is a good place to stop. So I'll see you in the next lecture.